All right, cool. We all pretty much ready to go? Thumbs up? Thumbs down? Rock on. All right. So our first up is Nate Warefield, and he has politely asked us to ask questions at the end since he has condensed a very dense topic and he wants to kind of get through it and respect everyone's time, and hopefully we can get it going. I created a Slack channel called Abstract Questions. So if you have a question and you want to get it in, please jump in that channel and we'll start sorting them through. If you guys are watching that channel a little bit, please feel free to thumbs up questions that you want answered, and we'll try and get those prioritized. All right? Cool. Here comes Nate.
Oh. Where'd my
displays?
There it is.
Are you doing the?
Not entirely sure what this is doing. I'm not really sure where my mouse went.
Oh, it's on the other. Bring it back to.
Hold on. Let's go like this. There we go. All right, good morning. Thanks for having me, everybody here that's running this conference. My name is Nate Warefield. I work for the Microsoft Security Response Center, and I'm going to tell you today a little bit about what I do in my spare time. Standard disclaimer, I have to say, none of the views that I'm expressing here are necessarily those of Microsoft. This is what I do in my own time when I'm not doing my day job. A quick thing about me, I do security vulnerability management for Microsoft. I own Hyper-V, Windows, Azure Metal to the VMs. Some of my battle-tested stuff that I've done in the last year has been MS-1710. I got to do WannaCry, NotPetya, Spectre Meltdown. If you want to hear some horrible details, come find me afterwards. My background is I did 18 years as a network engineer, and I've been a gray hat, I like to say, for most of my life. And you can find me on Twitter, GitHub. I don't put a lot of stuff on either of those places, but that's where to find me. This is a talk that I did. It usually goes about an hour, so I'm going to try to compress everything and be respectful. Find me if you have questions. Put them in Slack. So I kind of start this talk with a little anecdote. Back in 1998, I got my first cable modem, and what I found when I was talking to somebody on IRC was that I could point my Windows networking at their college network and restart it, open up Network Neighborhood, and immediately, well, as long as it took to load it across the internet, I could browse their subnets, right? I could start looking at all their file shares, do all this fun stuff. What the flip side of this is then 20 years later when I'm working for Microsoft, it took me 6 weeks to get a port open for DNS on a device, right? This is something that, you wouldn't think UDP 53 would be really that hard, but all of these things, all of these practices and the way that it changed from the late 90s till now was lessons we learned the hard way, which is, don't let everybody come in from the internet, put ACLs on things, put authentication on everything, install your security updates. Because I am part of the team that gets Patch Tuesday out, I'll repeat that. Please install your updates. And then, of course, all your internet-facing stuff goes into DMZ. You keep all your changes in your firewalls and ACLs, and your updates are done by different teams, and they're all responsible for making sure that your network is secure. What I found, as I said, I do a lot of vulnerability stuff for Azure. What we found is that as the cloud has taken off, I'm getting a little bit of feedback here. I'll try to. But as the cloud's taken off, a lot of this has changed, right? So every single VM, when you deploy it, it has to have some sort of internet access, right? It's not inside your network. You need to be able to connect in to manage these things. So it's usually SSH or RDP that's going to be turned on by default. The other thing that we found is, unlike the old model where it required a bunch of paperwork and signatures and people approving things, anybody that has subscription access can pretty much turn whatever they want on inside your subscription. This also means that your patch management is somewhat decentralized, right? You don't have a list of all the servers that you know about that you need to have all your updates installed, and whether it's Windows updates or apt-get update, apt-get upgrade. So that's starts to create these outliers that are a problem source. The other thing I found, and what I'm going to kind of focus on here, is that VMs deploy with these default firewall policies on them, and I'm going to touch on that more later on. The other thing that is really interesting about the cloud is when an image is updated or uploaded to the cloud or to an image gallery, it's done by the publisher, right? There's Microsoft. We have a bunch of stuff for Windows and different things for SharePoint, and we handle all of that. But there's a lot of third-party images, and the security setup that those things are uploaded with, it becomes essentially the copy-paste scenario where whatever I put up in this gallery is the security standpoint that it's going to deploy with by default. Any mistakes I make are going to be copy-pasted to everybody that deploys that image. This isn't unique to Azure. Like I work for Microsoft, so it's what I know the best. I've done some spot checking in AWS, and it seems that some of the stuff that I found here probably applies there. I'll go a little bit more into detail on that later. So 2017 was sort of the year that I considered was, it's all your cloud or belong to us, and I hope that I'm not dating myself with that meme. Now, the interesting thing about this is most of what I'm going to talk about is not, there's a little bit of cool zero-day stuff in here, but most of this isn't really cool zero days. These are really at cloud scale permissions problems. If you follow any of the work that Chris Vickery does, he's pretty much the guru of finding bad things in S3 buckets. I've stayed away from that in Azure just because it's a lot harder to do. But yeah, these are all stuff that I found, or all stuff that we saw in the news in 2017 that I'm going to kind of touch on. So how did I get going doing this? Back in 2016 in the fall, I started seeing some things happening with Redis, and it didn't seem to be that big of a deal at first. I thought it was a one-off. But it turned out it really wasn't a one-off. If anybody's ever worked with NoSQL, it's a SQL replacement. It's super easy to deploy, and it's also expressly not supposed to be opened up to the internet. All of these quotes are taken directly from the different NoSQL database solutions. There's a security page where they tell you, like, don't expose Redis to the internet. Only allow trusted clients to connect to Mongo, right? This is all, you would think this is network security 101, but as I found out, it's not, the things you think people know, it's not always true. So, of course, what do people do? Open them up to the internet. Starting in about January of 2017, let's see here, I think it was, I forget the chronology of it, but it was Mongo, Couch, Hadoop, Elastic. They all started getting owned. And what people were doing was they were connecting in, dropping the database, leaving a ransom note saying, hey, if you want your data back, send some Bitcoin to this address. The kind of brutal thing about it was they weren't even backing it up. So if you were foolish enough to go and pay the Bitcoin ransom, you're not going to get your data back because they just pulled a little Bobby Tables on you and left a note. Yes, I speak a lot in meme and humorous comics. Globally, there was probably over 100,000 systems that got owned. I remember going into a brew pub in Redmond and seeing their database, their menu board wasn't working. When I asked them, hey, what's going on? They're like, we don't know. Like our system went down, and our IT guys are trying to figure out how to get it back. And I was like, all right, that's probably what I've been tracking. In Azure, I found about 2,500. It was closer to 3,000 VMs that had this happen to them. And it went everywhere from demo systems to customer systems to stuff that our sales guys had probably set up and forgot was there. I can't go into details about any customers, obviously, because I can't. So how did I find this stuff? The interesting thing about finding these types of attack campaigns, what I ended up doing was going to Wikipedia, and after the first one, I went and looked up every NoSQL solution that was out there and just started sort of lather, rinse, repeat this process. Microsoft owns, we have about 21.7 million IP addresses that we own. About 1.6 million of those are internet facing. So that's a really large attack surface. And the thing that complicates this is that every NoSQL database is going to run on a different port. As you know, if you've ever port scanned anything, it's slow, it's expensive, it takes forever. And the other tricky part is like if I go and scan almost 2 million IPs for one thing, and I'm going to have to go back and scan 2 million IPs for the next thing, and over and over and over again. The other tricky part is that just because the port is open doesn't necessarily mean that it's been compromised. The NoSQL solutions that I called out, most of them do have a method you can turn on authentication, or you can, in some way restrict some access, right? The tricky part is a lot of them deploy without authentication by default, which is really where we saw people getting into trouble. So I needed a way to look at what are the database names on this thing? Is there any authentication? And a port scan isn't going to tell me this. So I know you're expecting something cool and fancy and Microsoft proprietary. No, I use Shodan. If you haven't used Shodan, it's amazing. I cannot say that Microsoft officially advocates the use of Shodan. I like it because I've been using it for 15 years. The nice thing is I can search by organization. It pulls all the database names. It connects in. If there's no authentication, it'll list everything there. So I was able to quickly search for things, and then since I'm dealing with possibly tens of thousands of records, I can download the results in JSON, write some code, and automate what I'm doing, which made it really easy when I wanted to go and go to the next database solution. I could, to a degree, sort of use my same code. One thing I'm proud of is that after doing this, I ended up writing some extra code, and I talked with John, who runs Shodan, last fall, and I said, hey, we really should have a way that you can catch this stuff automatically. So he was nice enough to add my code to Shodan in December, and now if you've got an enterprise license for Shodan, you can actually just search for tag compromise, and it'll tell you in real time how many databases are out there that it's seen that are compromised. I'm really happy at how low this number is. You would think I'd want to see a lot of them. It's nice to see not even 20,000 of these things that have been owned. So you do need the Shodan Enterprise license. It's not exorbitantly expensive if you work for a big company. Or you can find my code on GitHub. I had a hideous URL in there. You can just go. I think that'll get you right to it. There's literally one piece of code in my gist on GitHub. So going from there, from NoSQL, right? I was pretty proud of the stuff that I'd found with NoSQL, and it kind of enthused me to go find some more stuff. Fortunately for me, I didn't really have to wait very long. If anybody is familiar with the shadow brokers, so there was a government agency that had a really cool SMB v1 exploit that they'd had for God knows how long, and they turned it into a really nice tool that they built, kind of the Metasploit clone, and oops. So I hate it when I lose my exploits because this was a beautiful exploit. I got to work the incident response for this, and it was an absolutely elegant thing. Not really allowed to say who it was verbally, but we all kind of know who it was. So we patched this in March. It was one of those things. I was involved with this project pretty much from when we got the exploit from some unnamed people. And we were really proud of ourselves that we'd gotten, for once, Microsoft had gotten something done ahead of time. Instead of being reactive, we were being really proactive. And of course, when we released this patch, we don't really go into huge detail as to where we got this exploit or what exactly you could do with it. And we figured, okay, that's fine. Nobody in their right mind is going to put SMB on the internet, right? Yeah, I thought so too. Once the shadow brokers decided to release their password for the equation group files, everybody started playing with it because what else are you going to do with somebody's really cool exploits that just sprayed at the internet? So there was as soon as this came out and we got done with the fire drill of figuring out, did we patch this or did we patch everything? Like, we spent an entire Friday taking apart all of that files, all of the data in there, testing it against every version of Windows. And by Friday night, after the shadow brokers had released it, we were really proud to be able to say everything has been patched. Like, all of these exploits have been patched. If you installed the March patches, I think it was April 12th that the password was released. So we were like, cool, 30 days later, everybody's patched, right? So I decided to go and look and say, okay, well, how many people have double pulsar? Like, somebody's spraying this at the internet. There was a group out there, I believe it was NCC group, that wrote some Python code that would allow you to do a connection to this SMB server. The elegant thing about this exploit and their implant that they call double pulsar was you could send a request, you do an SMB session setup, you send this weird thing that was a non-implemented command in SMB, and then any normal SMB server is going to respond with just an error, like, I don't know what that is. If you'd been implanted with double pulsar, it would respond with an error, but a very specific error code. So the presence of this error code allowed you to test for whether double pulse solver is there. So it didn't really alter the system. There was no way to find it other than quite literally grabbing all of the IP addresses and running this piece of Python code against it and testing it. And I'm like, okay, cool. So as I'm looking at it, I'm like, okay, there's like only 50 machines that have gotten hit with this thing out of like 14,000, right? So that must mean that everybody patched. I mean, right on, you know? So we thought. About 28 days later, this thing called WannaCry hit. Most people have probably had to deal with this in one way, shape, or form. I'm not going to go into the details of what we at Microsoft did for WannaCry. I can't. But it started in May 12th. It targeted systems that did not have these MS-1710 patches installed. The initial, there was almost 250,000 machines that got hit by this over 150-odd countries. And the initial infection was, I believe, through a SMB port from a system somewhere in Asia, is what the news media that I was able to find were saying about this. Its lateral movement really was through the same exploit, through this MS-1710, as we call it, or Eternal Blue was the code name from the unnamed agency that used it. And this was a fairly low-tech attack, right? This is, it's 30 days after this thing, or 28 days after this thing was released. You could tell that it looked like a script kid. You just put a wrapper around this thing and put some ransomware code in there and said, okay, let's just point it out there on the internet and see what it does. At the time, when WannaCry hit, Azure's exposed SMB count, I actually run a database that collects Shodan stats every day, so I can pull an exact number of how much SMB we had on that day. There was 14,000 hosts that had exposed SMB. Once again, I can't go into how many of those might have hit with WannaCry, unfortunately. Find me later. So about 6 weeks later, NotPetya hit. And the interesting thing with NotPetya was that it was a very targeted attack. Unlike WannaCry, which was just sort of like fire and forget and see how many things could go after, this one was, for all intents and purposes, targeted at the Ukraine. For those that aren't familiar or intimately involved with this, they backdoored this MEDocs tax software, which is really only used by Ukrainian businesses. Once they'd backdoor these update servers, they were able to stick their payload in an update and then say, hey, you've got an update for your tax software, which, lo and behold, brought NotPetya into your environment. The elegant thing about this is unlike WannaCry, which just looked for missing patches and would just try to blast them with this exploit, this thing actually had lateral movement with all of our favorite vectors, right? You've got PSExec, you've got Mimikatz, you've got WMIC, and then if all else fails, you could hit it with MS-1710. The thing that makes this really spooky to me is that any business that's like, okay, we think we got everything patched, right? All you needed was one machine that wasn't patched, right? As soon as you have one machine that's not patched, all your patched machines are still screwed because I can laterally move with Mimikatz and it's still game over, right? The blast radius on this, and this kind of goes into the stuff that's theory. I've tried to find out if this is 100% true or not. I'm working on the threat ops and intel that we had, that the VPN links from businesses outside of the Ukraine is really what caused this thing to propagate farther. In fact, we had one of the Microsoft satellite offices that got hit with this. I'm not entirely sure how they got hit, but it was fairly devastating for a day for them. Obviously, for Maersk, it was a lot worse. They took something like $350 million worth of loss. The news I was reading last week said they had to reinstall like 45,000 client machines and like 5,000 servers. I mean, if you're not a huge company, this is devastating. This is just close your business. It's done. You're over. And this was fairly high tech, right? The thing that makes this interesting too is I don't know about your exploit development and your teams, but taking a release tool and in like 2 months, 74 days after the Equation Group files were made public, this thing was out there. That's a really quick turnaround to build a weapon of this sort of elegance. I can theorize as to where this might have come from. I won't. What's interesting too is that the Azure exposed SMB by the time this thing had gone up 13%. So while you would think that everybody would say, okay, well, there's WannaCry, maybe I should firewall off my SMB ports, it's not true. I can't exactly tell why there's so many more. My suspicion is that more people were spinning up machines. These numbers that I'm counting for you they're not operating system. This isn't necessarily Windows machines. There is a lot of stuff in Azure that you can deploy that speaks SMB, that's Linux, that's file servers and stuff like that. That's not necessarily Windows. So it was just interesting. If I was a network guy, as soon as WannaCry hit, I'd be like making sure that everything turned SMB off pretty much everywhere. So this got me thinking. With a cloud subscription, right, you've got this issue where you've got this decentralized network. It's sort of, a lot of people look at the cloud as like, it's just this cloud network. It's not my corporate network. Whatever, it's fine. There's this thing called ExpressRoute that Microsoft sells, and it sounds like a VPN. It is. You can, if you have enough money. Questions? Oh. Okay. So it sounds like a VPN, and it is. It's basically a direct connection from your corporate network back into your cloud network. So the thing that's spooky about this is somebody pops your cloud subscription and you've got ExpressRoute. Like, as I was saying, the lateral movement through Mimikatz and everything else could pretty much decimate you, even though you think your cloud is isolated from your corporate network. Amazon has a similar type of thing. They call it Direct Connect. I haven't been able to play with any of these because they cost an exorbitant amount of money, and I don't get free access because I work for Microsoft. But it gets me thinking in that sort of evil mindset, like, what could you do, right? Now, how could you get into somebody's network from their cloud subscription? It's unexplored. It's interesting. If anybody wants to play with this, let me know. What I ended up doing, because I was wondering about why people are doing these bad things, is then I started digging into what these firewall policies are for the VMs that get deployed. And in Azure, we call it a network security group. And this is the hard-coded firewall that comes with your VM image. It's set up by the image vendor once they upload the image to the gallery. You can configure this thing when you're deploying your VM, but you don't have to. In fact, in Azure, it doesn't even ask you, do you want to look at these settings? I am working to try to get that fixed and have it highlighted. But right now, if you deploy, it just comes with this firewall that they set up for you. When I did some coding against this and reversed our API a little bit, I found out that 46% of the 2,500 or so images out there have this default firewall configured. And of those, like 96% of these things expose more than just a management port. As soon as you turn it on, I think the worst offender opens up 83 ports in your firewall. Now, I want to highlight the fact that Microsoft's images are, by and large, far more secure than the third-party companies that we see. And I've reached out to a few of them, and I've had differing levels of success. Some companies are like, holy crap, we didn't realize we opened up Mongo to the internet by default. And in like 24 hours, they'd fixed their image, re-updated it, pushed it into the gallery, and all was good. There's 500 different ports that I found that get exposed. Like I was kind of amazed to see how many different things people are opening up in an Azure firewall policy. Your standard, 8443, RDP, SSH, but then there's all sorts of weird database stuff. People are opening up old NetBIOS ports and things like that I'm just like, why on earth would you expose that to the internet? Some of these vendors even said, well, it's fine because we have a firewall, host-based firewall on the VM. I'm like, yeah, but it's a cloud image, so your host-based firewall is probably open any on that port too. Like, it's not really an excuse. I did a little bit of looking into Amazon, and their AMI, they call it an AMI security group. It's basically the same thing. Now, I wasn't able to programmatically look at all of the images in their marketplace the way I could with Azure. I did talk to AWS, and they filed a feature request for me to add this functionality. It's been sitting for a while. If anybody here works for AWS or has good contacts, I'd love to chat with you, not because I'm trying to do competitive analysis. I'm mostly just trying to do comparative and say, hey, I'm happy to share the things that I find with whoever at Amazon may be interested. So yeah, the spot checks I've done, like just on a handful of things, have shown that they have about the same issues. They've got a lot more images in their cloud gallery. They've got like 21,000, so obviously I can't go through their GUI wizard thing and deploy each one and count the ports that they open up. So like I said, I'd really love API access. I think I'm running out of time here. The other thing I found in Azure and probably AWS as well is that sometimes the descriptions on these gallery images will come with a password that's set by default. But at least it's a strong password. This is not exactly the password, but it's basically the password. I'm not allowed to brute force things, so I don't know how many people have changed these. But it does say, hey, change this when you deploy it. Don't leave this open. Fortunately, it's only for things like MySQL and SQL and stuff that really matters. I mean, granted, this is worldwide statistics, but my question really comes down to, like, do you really need to open up your database to the internet? It just seems like a bad idea. And especially if people are having these passwords that they're like, it's a good password, I'll leave it. And it's always the thing you're going to forget to change, right? You're going to leave it while you get it working, then it's working. That's good enough. So, which kind of brings me to the end of my very compressed talk. I believe that this year is going to be less of the ransomware and more of the crypto miners, right? So ransomware is very low yield. This kills the host. As soon as it happens, it's noticeable. Your machine stops working, your server goes down, nothing works anymore. So ransomware or crypto mining software, on the other hand, is becoming extremely popular, right? So you can make a lot of money with this. You can make a lot of money stealing other people's resources, which I was really bummed that I didn't get in on Monero last year when I thought I should. Had I wouldn't even have to work anymore. But the interesting thing is we're coming into a day and age where it used to be really hard for me to steal your resources, right? I could pirate your software, I could steal your music, maybe even steal your movies, but that's sort of theoretical loss, right? Now I can actually steal electricity from you, and I can turn it into currency. I can turn it into something that's got tangible value for me. And this used to be almost impossible. It's not anymore. I found this a couple weeks ago when I was putting these slides together. This one Oracle vulnerability netted these guys to $250,000 worth of cryptocurrency in a couple of weeks. Almost not noticeable, and if you've ever used Oracle, you know what those things run on. It's big, heavy, beefy servers with lots of CPUs. So, yeah, until now, it's been hard. So, sweet. I actually have a few minutes for questions, it looks like. If anybody has any, or you can always find me afterwards.
Are there any sort of big data analytic solutions, Splunk, help that can help kind of identify some of these, I guess, different facets of what you've identified, like from reports to...
So in Azure Microsoft, we've got some solutions that we'll sell. Like there's Azure Security Center and then what we call OMS that are designed to help you keep. Oh, I'm sorry. The question was: is there any sort of solutions like Splunk or others that would help you sort of narrow in on these facets and see that they're there from a big data perspective? Yes and no. I know Azure's got what we call Azure Security Center. There's OMS. These are designed to sort of help you look at what your port configuration is, tell you if all of a sudden somebody adds a weird VM, from some other country that you don't do business in. A lot of what I've found is these third-party solutions. If you're not paying attention, you're not going to notice it. I know that AWS, somebody released some code recently that you can run it against your own AWS subscription, and it'll tell you what your firewall policies are, and if you're in a good security standpoint. I'm kind of working in my spare time on trying to build something like that you could just point it at your Azure sub and say, tell me what my security standing is, and it'll tell you, like, you've got some bad things open. But yeah, that's what I know today. This is all, like I said, this is all stuff I do in my spare time. Yeah. I'll repeat your question.
So I've been doing a lot of programming against AWS, interested in checking out Azure. One of the things that I think is pretty interesting with a lot of these cloud providers is that they allow you to sort of script everything end to end. So at least with AWS, I can deploy users, policies, groups, roles, etc., and I can lock that down from the deployment. So what to me is interesting is that my code can essentially, my security, my setting up of my infrastructure can essentially be checked in as code. I can write unit tests against my cloud deployments. Do you see, I don't know in Azure if they have that many APIs and that ability to scale. I imagine they do.
They do.
And there's Terraform, which kind of abstracts on top of that. Do you foresee that alleviating some of the security concerns, that people can essentially code security into their deployments?
Yeah, absolutely. I know with Azure, there is when you're doing a deployment, you can actually save what your predefined config is and say you can create a deployment template, right? So you can say you're going to have to set up like 100 NoSQL boxes. You can design your config, set it up the way you want it, and then you can take this deployment template and then you can just reuse it. That is the right way to do things, right? The issue that I think we find is that if you're a security-minded person deploying in the cloud, you're going to be okay. The place where people get into trouble is they have this subscription and they're like, all right, their DevOps dude's like, hey, can I have access? I want to spin something up. And he's doing it outside of the normal controls that you'd have. But yeah, you're absolutely, if it's done programmatically and there's somebody that has the oversight, there's no reason you can't have just as secure a deployment in Azure or AWS.
So after about a year, Amazon finally changed the S3 interface so that there's a big red dot if you have an S3 public bucket. It took them about a year for that feature request to roll out. why aren't there more of those, right? If we as a room full of security professionals are pretty clear that SMB to the internet is 99% a bad idea. Why, do you have any perspective on why Azure doesn't bake more of those directly into their interface?
Well, that's a great question, and honestly, like I said, with Microsoft, we've got a lot of the stuff that we deploy. Like I can pull out all of the stuff that's Microsoft images, and none of them. They all have RDP, and that's basically it. The tricky thing is there's very little oversight that I've found into what third-party groups that are uploading into the galleries are. Right. I tried setting myself up as a marketplace vendor, and it was basically show us your business license, pay a fee, we'll vet you, make sure you're actually a company, and after that, you're good to go. Upload whatever you want. Right? So the evil side of me is like, what could I upload and make popular and mine coins in the background? But I'm not allowed to be that evil.
Anybody else? All right, cool. Thanks, Nate.
Thanks. Anybody who has any questions, find me afterwards.
If Daniel's in here, come talk to me.